Let's try a problem together that's going to help strengthen your understanding of some concepts to get you ready for the AP Calc AB exam. The concepts covered in this particular problem will show up between 9 and 13% of the time on the exam. If you'd like to try the problem on your own, feel free to pause the video first to go ahead and do so. Otherwise, let's go ahead and go over it together. If sine of the quantity of x plus y is equal to 3x minus 2y, then what's dy dx? So here's our original equation, and if we want to find dy dx, we're going to take the derivative of both sides of this equation, so we should be thinking of implicit differentiation. So let's go ahead and do that. Let's take the derivative of both sides of this equation. Alright, so using implicit differentiation, we're going to take the derivative of both sides. Now if we take a look at the left side of the equation, we hopefully see here that we have a sine function, so it's sine of something, but then we also have this function of x plus y inside of that. So this is a composition of functions, so what comes to mind? Hopefully you're thinking of the chain rule. With the chain rule, we have this outside function of sine of something, and on the inside function, we have this x plus y. So we have this f of g of x kind of scenario. So if we go ahead and take the derivative of this function here using the chain rule, the derivative of sine of x is going to be cosine of x. So in this case, it's going to be cosine of whatever's inside. In this case, it's going to be x plus y. But then we have to go ahead and multiply this by the derivative of the inside function, which is going to be this x plus y. Now, the derivative of x is just going to be 1. Let's go ahead and open a parentheses here. Let's go ahead and put 1 plus, and then the derivative of y is also going to be 1, but keep in mind that we're also going to have this dy dx, right? So we'll put 1 times dy dx or just dy dx. So this is right here going to be the derivative of the left side of the equation. For the right side of the equation, we have the derivative of this 3x first. Now the derivative of that is just going to be 3. And then we're going to go ahead and take the derivative of this 2y here. Let's put a minus here. And the derivative of 2y is going to be 2, but then we also have to multiply this by dy dx. So the trickier part here was finding the derivative of the left side where we use the chain rule. All right, now remember, we're trying to find out what dy dx is, so let's go ahead and see if we can use some algebra and just get these two dy dx's and consolidate them into one. Let's start by taking this cosine of x plus y and distributing it to both of these terms inside here. If we do that, we're going to get and on the right side of the equation, we're just going to keep this 3 minus 2 times this dy dx. All right, this is going to be a little bit easier to move some things around now. Let's go ahead and take this term and put them on the same side of the equation. I'm going to go ahead and add this one to the left side of the equation. Then I'm going to go ahead and subtract this term, so it's going to go to the right side of the equation. If we do that, we're going to get this equation right here. All we did in this line was distribute, and in this line we reorganized our terms to get the dy dx's on the same side. Next, notice that these two terms both have a dy dx as a common factor, so let's go ahead and factor it out as the GCF. If we do that, it's going to look like this. And for one more step, we can get this dy dx alone if we just go ahead and divide both sides by this cosine of x plus y plus 2. Dividing both sides, we're going to get this expression right here. And so just moving around a couple pieces at the end there, isolated our dy dx. Looking at our answer choices, it looks like we'll go with D here. That'll be our answer.